Hi everybody, sorry I can't make it there today. I'm not feeling the best. So instead you'll just be watching an ed puzzle. We'll go through the notes together. My expectation is that what I'm saying, what I'm writing, you are also writing on your paper. So your blue packet should be filled out as I am going through the notes with you. When you're done with this blue packet, then you can move on to your 4 homework questions for today. So we're going to look at lesson 7.1.5, what if there are more than 2 events? So yesterday we practiced the probability tables. That's when we had the dice and we had 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, and then we filled in all of the boxes, and with that we were able to see that getting a sum of 2 or 12 had a probability of 1 out of 36. We also saw that rolling a 7 or a sum of 7 had a probability of 6 out of 36. Today we're going to focus on what they call probability trees. So for question 41 on your blue packet, you are going to see this spinner. Here's what I want you to do with problem 41. Cross it out, right? Skip. This doesn't talk about the probability tree, so we are going to skip it. So for question 42, it says Scott's job at Crazy Creations ice cream shop is to design new ice cream flavors. The company has just received some new ingredients, and Scott wants to be sure to try all of the possible combinations. He needs to choose one item from each category to create the new flavor. So we are going to use what we call a probability tree to solve this, to see how many different flavor combinations and new flavors can he make if we have vanilla and chocolate ice cream, if we have hazelnuts, sprinkles, and toffee bits, and then for the fruit swirls, apricot, plum, berry, and grape. So if you look at your probability tree, we're starting off with the 2 different options. So we can either have vanilla or we can have chocolate ice cream. That's kind of like our base. You can do one or the other. Let's start by focusing on the vanilla. So for the crunchy add-ins, with vanilla ice cream, we can have hazelnut, we can have sprinkles, or we can have toffee bits. Then there's the additional fruit swirl. So for toffee bits, we can have an additional fruit swirl of apricot, plum, berry, or grape. What I want you to do is to fill in the rest of the probability tree by the hazelnuts and sprinkles. So if I have hazelnuts, the possibilities of the fruit swirl are apricots, plums, berries, and grapes. For sprinkles, we could do apricot, plum, berries, or grapes. Those are all of the combinations for vanilla ice cream. We could have vanilla with hazelnut and apricot. We could have vanilla, hazelnut, and plum. Vanilla, hazelnuts, berry. Vanilla, hazelnuts, grape. So this is just a way of showing all of the different flavor combinations that we could have. So for chocolate, again, we're starting with that crunchy add-on. There's the 3 different kinds. So I want you to write into this table. We've got hazelnuts, we've got sprinkles, and we have the toffee bits. And then same thing as the one above, we then have the flavor swirls, which would be apricot, plum, berry, grape. Apricot, plum, berry, grape. Apricot, plum, berry, grape. I want you to take a pause, and I want you to make sure that you have this entire tree, probability tree, filled in. Okay. We're going to use this probability tree to answer questions C, D, and E. So for letter C, it says how many different flavor combinations are possible? Where do you look on the diagram to count the number of complete combinations? So for this one, we're going to count all of like the final products. So like this would be 1 because it's vanilla, hazelnut, apricot. This would be 2, it's vanilla, hazelnut, plum. 3, 4, we're going to count how many total end products they are. So 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So for C, it's going to be 24 flavor combinations possible. It says use the probability tree to help you find the probability that Scott's final combination will include a plum swirl. So what I want you to do is out of the 24 total, I want you to go count at the end there in that red highlights, how many of those 24 include a plum swirl? There are 6 total plum swirls for this problem. So we could write that as 6/24, 1/4. I would accept 25/100. Any of these, or 25%, any of these would be the right answer. For the next one, for E, what is the probability that his final combination will include hazelnuts? So I want you to go through and I want you to count all of the possible outcomes that are going to have hazelnuts. Okay, so for the hazelnuts, there are going to be 4 final ice cream combos that include hazelnut for vanilla, and there's going to be 4 final hazelnut ice creams for chocolate. So that means there's going to be 8 out of the 24. We have 4 here and 4 here. That would include hazelnuts. Okay, for question 43, it says Scott's sister loves hazelnuts and Scott's little brother loves grape. So recall that events are favorable outcomes. List all of the outcomes in Scott's sister's event. Remember, the sister is the hazelnuts. So we're going to look through and we're going to count and figure out, okay, how many are going to include the hazelnuts. So she could do vanilla, hazelnut, apricot. She could do vanilla, hazel, plum, vanilla, hazel, berry, and vanilla, hazel, grape. She could also then do the chocolate, hazelnut, apricot, chocolate, hazelnut plum, chocolate, hazelnut berry, and chocolate, hazelnut grape. So these are all of the outcomes that his sister would be happy with because they are the ones that include the hazelnuts. For his brother, he loves grape. So we're going to go through and we're going to look at, okay, which ones include the grape. So we could have the vanilla hazelnut grape. We could have vanilla sprinkles grape. We could have vanilla toffee grape. We then could have the chocolate hazelnut grape. We could have the chocolate sprinkles grape and the chocolate toffee bits grape. So for B, it says that 2 events are mutually exclusive if they have no outcomes in common. Do Scott's sister and little brother have mutually exclusive events? So for this one, we want to look, are there any flavor combos that show up in both of their interest? So at first glance, I see that they both have the vanilla hazelnut grape in common. And they also have the chocolate hazelnut grape combo as well. So these events would not be exclusively mutual because they have the things in common. They both would get the vanilla hazelnut grape and they both would get the chocolate hazelnut grape. It says, what 2 mutually exclusive events in the Crazy Creations ice cream shop could be? So you're looking for 2 of the final outcomes that have no pieces in common. So, for example, if it's like vanilla and chocolate, because you're never going to have both of those. It could also be berry and grape, because you're never going to have both of those. For question 44, it says, in a power outage, Rona has to reach her closet in the dark to get dressed. She's going to find one shirt and one pair of pants. She has 3 different pairs of pants, one black, one brown, one plaid. She also has 2 different shirts, one white and one polka dot. So at first glance, I want to organize my data here. For pants, we have black, brown, and we have plaid. And then for the shirts, we have white and polka. It would help if I could spell. There we go. So it says, draw a probability tree to organize the different outfit combinations that Rona could have. So let's start with the 3 different types of pants. So you want to make sure that you're drawing this probability tree on your notes as well. My 3 different types of pants are black, brown, and plaid. Then you want to list out all of the shirt combinations for each pants. So if she picked out black pants, she could then pick out a white or a polka dot shirt. For the brown pants, she could pick out a white or a polka dot shirt. And for the plaid pants, she could pick out a white or a polka dot shirt. So pause to make sure you have the same probability tree that I do. So for B, what is the probability that she will wear both a polka dot shirt and plaid pants? So the first thing I need to do is realize, okay, how many total possibility outfits are there? We have 1, 2, 3, 4, 5, 6. Remember, we're always counting that like far right, how many total would there be? Out of those, if it's polka dot shirt and plaid pants, that would be this combo right here. So that would just be 1 out of 6. What is the probability that she will not wear black pants? So that means that she'd have to wear the brown or the plaid. I want you to pause and see if you could figure out what would the probability be then of not wearing the black pants be. The probability for this one would be 4 out of 6, or I would accept 2/3. For D, for what kinds of problems can you also make a probability table? If it's possible, make a probability table for Rona's outfits. Which way of representing the outcomes do you like better? So if you were to do your probability table, I'll just do it down here so you have some more space. On the top, we could do the polka dot shirt and the white shirt. And then on the side, we could have the plaid, the brown, and the black. And then your possible combos then, you could have the plaid and polka. You can do the plaid and white. You could do the brown and polka. You could do brown and white. You could do black and polka, black and white. These work too. Honestly, it's going to be your preference on what you think kind of makes the most sense to you, if you like the tree or if you like the table. I personally like the tree. To me, it's an easy way to see it, but like I said, it's your choice. Are the events polka dot and plaid mutually exclusive? Remember, that means that if they're mutually exclusive, they cannot happen at the same time. So if I go back and look, there is a possibility that I will wear plaid and polka. So that will not be mutually exclusive. Are the events that polka dot and white mutually exclusive? If you look back here, those are my two shirt combinations, so it is not possible for me to wear these at the same time. Okay, you're either wearing one or the other. So this would be mutually exclusive. We are going to stop here. If you are feeling a little hesitant about the tables and the trees, do not worry. We are going to review the next 3 days about these. This is just kind of an introduction. Your task for the remainder of class is to do the 7.1.5 homework. You have problems 47, 48, 49, and 50. Once you finish those, if you have extra time, please do any of your missing work. You can do Prodigy. You can do a math look it. You can read. You can draw. Please no other games besides the 2 that I have listed here for you. Thank you. I look forward to having great subplans when I return tomorrow.